Welcome back to the Learning Den. I always say there's nothing more fascinating than really getting to the bottom of, these huge topics like where did we come from?
Mm,
And today we're going to do a deep dive into human origins.
sounds exciting.
It is.
Hmm.
And we've got a lot of ground to cover.
We do.
So let's jump right in. Now, where do we even begin with something as massive as human origins?
Well, I think the best place to start is by addressing a common misconception that a lot of people have. You probably heard this one, that humans were around during the time of Pangaea, that supercontinent, millions of years ago.
Right, I've heard that too.
Yeah, well, it's a cool image to think about, like humans roaming around with dinosaurs.
Oh, yeah.
But unfortunately, it's just not true.
Okay, so why not? Bust that myth for me.
So Pangaea existed way back like 335 to 175 million years ago, give or take. And the dominant life forms back then were, plants, insects, amphibians, and reptiles. Eventually, dinosaurs entered the scene, but early primates are distant relatives. Those guys didn't even show up until around 65 million years ago.
Okay, so way after Pangaea had already broken apart.
Exactly.
So no humans riding dinosaurs then.
Oh, no. Sadly not.
Well, too bad. But, okay, it does put things into perspective, right? I mean, we're talking about these vast timescales, hundreds of millions of years.
Absolutely.
And modern humans, Homo sapiens, we only emerged, like 200,000 years ago?
That's right.
It really makes you feel kind of small in the grand scheme of things, doesn't it?
It really does. It's humbling to think about just how vast geologic time is. And our existence is just a tiny blip in comparison.
A tiny blip, but a pretty significant one, wouldn't you say? I mean, look at what we've accomplished.
Absolutely. And within that blip, human evolution has unfolded in some truly remarkable ways.
Okay, so let's rewind that evolutionary clock. Let's trace those key steps from our earliest ancestors to modern humans. Where do we even begin with that?
Well, imagine Africa about 6 to 7 million years ago. That's where the very first human-like ancestors, the hominins, emerged. One of the earliest we know of is Sahelanthropus judensis. Based on the fossil evidence, we believe they walked upright, which was a huge evolutionary leap.
Walking upright. So even before Lucy, that famous Australopithecus fossil we all know and love.
That's right. Australopithecines came a bit later, around 4 to 5 million years ago. Lucy specifically, she was an Australopithecus afarensis. She lived in East Africa about 3.2 million years ago.
And her discovery was a big deal.
Oh, absolutely. Her fossil remains are remarkably well preserved, and they've provided us with incredible insights into our early ancestors.
So walking upright, or as the fancy folks call it, bipedalism, seems like it was a pretty pivotal moment in our evolution. What kind of advantages would that have given our ancestors?
Well, for one thing, it freed up their hands for tool use, which became crucial for their development. It also allowed them to see further over the grasslands, which could have helped with spotting predators or finding food. And walking upright is more energy efficient for long distances, potentially giving them an edge in exploring new territory.
So they could travel farther and see better and use their hands for more than just walking. That's a lot of advantages packed into one adaptation.
It really is. And those early adaptations set the stage for everything that followed.
Right. So we have these early hominins walking upright, exploring the African landscape. But we're still a long way from modern humans, right? What was the next big step?
Well, around 2.5 million years ago, another big shift happened, the emergence of the genus Homo, also in Africa. And that's where things start to get really interesting.
Okay, I'm all ears. What happened with Homo?
Well, early Homo species, like Homo habilis, they were known for using simple stone tools.
So they started making tools.
Yeah, they were pretty rudimentary, but they marked a crucial step in our technological advancement.
Okay, I can see how that would be important. What does that tell us about their capabilities compared to the earlier hominins?
Tool use suggests a significant leap in cognitive abilities. It indicates an ability to plan, to problem solve, and to manipulate their environment in more complex ways. These early Homo species weren't just adapting to their world anymore, they were shaping it.
That's amazing. From simply walking upright to crafting tools, that's quite a progression.
It's a remarkable story of gradual change and innovation. And this innovation continued with Homo erectus appearing around 2 million years ago. They were the first hominins to venture out of Africa, spreading across Asia and even into parts of Europe.
Wow, so they were the pioneers, the explorers.
Exactly. They adapted to all sorts of diverse environments, paving the way for the global expansion of our species. They developed more sophisticated tools, mastered fire for warmth and cooking, and likely had more complex social structures.
So it's like each adaptation led to new possibilities, new opportunities, which led to further expansion.
Absolutely. It's like a snowball effect.
But wait, we're still not quite at Homo sapiens, are we?
Not yet. But the arrival of Homo sapiens, That's the final chapter of our story, at least for this deep dive. And it all leads back to Africa once again.
Africa, the cradle of humankind. But okay, let's talk about this evidence. What makes scientists so confident about an African origin for Homo sapiens?
Well, one of the most compelling pieces of evidence comes from our genes, specifically mitochondrial DNA, which is passed down directly through the maternal line.
Oh, right. Mitochondrial Eve. I think I've heard that term before.
Exactly. By studying mitochondrial DNA, scientists have been able to trace all living humans back to a single female ancestor who lived in Africa sometime between 150,000 and 200,000 years ago. Now, this doesn't mean she was the only woman alive at the time. It simply means that hers is the only lineage that has survived unbroken to the present day.
So she's like our great-great-great-grandmother a million times over, the mother of us all.
In a way, yes. And the story is further supported by studies of the Y-chromosome, which is passed down through the paternal line. Similar tracing techniques have identified a Y-chromosomal atom also living in Africa between 200,000 and 300,000 years ago.
So two separate lines of genetic evidence, both pointing to an African origin. That's pretty convincing. But is there anything else that supports this out-of-Africa theory?
There is. Let's look at genetic diversity. African populations display the highest levels of genetic diversity compared to other populations worldwide. As groups migrated out of Africa, they carried only a subset of this diversity with them. So the farther you move from Africa, the less genetic diversity you find.
It's like a family tree branching out with each branch carrying a portion of the original genetic information.
Exactly. And this pattern of decreasing genetic diversity with increasing distance from Africa strongly supports the idea that modern humans originated in Africa and then dispersed throughout the world.
So we have these genetic markers pointing back to Africa, and this pattern of decreasing diversity as humans spread out. It's like a trail of breadcrumbs leading us back to our origins. But what about fossils? Do they tell the same story?
They do. The oldest Homo sapiens fossils have been found in Africa. For instance, the fossils from Jebel Irhoud in Morocco, they date back an incredible 300,000 years. And those from Omo Kibish in Ethiopia are around 195,000 years old.
Okay, so we have the genetic blueprints and the fossilized remains, all pointing to Africa. It's a pretty remarkable story when you think about it.
It really is, and this is just the beginning. Next time, we'll explore how these early Homo sapiens ventured out of Africa and spread across the globe, adapting to different environments and ultimately giving rise to the incredible tapestry of human diversity we see today.
That sounds like a great place to pick up in part 2 of our deep dive. Stay tuned as we unravel those amazing forces that have shaped our species and continue to influence our evolution even today. Welcome back to the Learning Den. Last time we were talking about, how all the evidence points to Africa as the birthplace of Homo sapiens, which is pretty amazing when you think about it.
It is.
But then it makes you wonder, if we all came from Africa, how did we end up with, so much diversity in human populations all over the globe? Like, how did that happen?
That's a great question, and it's one that's fascinated scientists for a long time. The answer lies in a complex interplay of factors like environmental pressures, genetic drift, and even cultural practices, all shaping us over time.
Okay, so let's break that down a bit. What are some of the most, obvious examples of human diversity, and how did those variations come about?
Well, let's start with something we all notice right away: skin color. It might surprise you to learn that variations in skin pigmentation actually evolved as an adaptation to different levels of UV radiation.
Oh, right. Like as Homo sapiens migrated out of Africa and spread to different parts of the world.
Exactly.
I remember learning about melanin, the pigment that gives our skin its color, and it also acts like a natural sunscreen.
That's right. So in regions close to the equator where the sun is really intense, darker skin would have been a huge advantage.
Because it would have offered better protection from the sun's harmful rays.
Right. In places like Africa with high UV exposure, darker skin with more melanin would have protected against skin cancer and other sun-related issues.
And then as humans move farther away from the equator, like to regions with less direct sunlight, the need for darker skin would have decreased.
Exactly. In those areas, lighter skin, which allows for more absorption of UV radiation, would have become more beneficial.
Because they needed that UV radiation to produce vitamin D.
Right.
Which is super important for bone health.
Precisely. So it was this delicate balance. Too much sun is harmful, but too little sun also has its downsides.
And our skin adapted to find that perfect balance based on where people lived.
It's a remarkable example of how adaptable human evolution really is. And it's not just skin color. We see these adaptations in body shape, too. Have you ever heard of Bergmann's rule and Allen's rule?
Oh, yeah, vaguely. I think it was from biology class, something about body size and proportions and climate.
You got it. So picture this. You have two groups of people, one living in a freezing cold Arctic environment and the other living in a hot tropical rainforest. Bergman's rule says that people in colder climates will tend to have larger, more compact bodies.
To conserve heat better, right?
Exactly. Smaller surface area to volume ratio, minimizing heat loss.
So like the Inuit people in the Arctic with their stockier builds.
Perfect example. And then on the flip side, in hotter climates, people tend to have taller, leaner bodies, which are better at dissipating heat.
Like the Maasai people in East Africa with their long limbs.
Precisely.
It's incredible how evolution just fine-tuned those features over generations to help people survive in their environments.
It really is nature's way of optimizing for survival. And then Allen's rule adds another layer to this. It states that animals in colder climates tend to have shorter limbs and appendages.
To minimize heat loss again, right?
Yeah.
So it's not just about overall body size, but also limb proportions.
Exactly. Shorter limbs in colder climates, longer limbs in hotter climates.
It's fascinating how these rules are reflected in human populations all around the world.
And these adaptations can be subtle, but over time they lead to some pretty significant variations in appearance. Even something like nose shape can be influenced by climate. Have you ever noticed how nose shapes differ across different groups of people?
Now that you mention it, yeah. Why is that? Like, why do some people have wider noses and others have narrower noses?
That's another adaptation. In hot, humid climates, broader noses, like those often seen in people of West African descent, have evolved to help humidify and cool the air before it reaches the lungs.
So a wider nose acts like a natural air conditioner.
You got it. And in colder, drier climates, narrower noses, like those commonly seen in people of European descent, are more efficient at warming and moistening the air before it hits the lungs.
So again, it's about adapting to the specific environmental challenges.
Exactly. It's amazing how these small details have been shaped by natural selection over time. But we've been talking a lot about physical adaptations. What about cultural practices? Have those played a role in shaping human diversity too?
Oh, that's a good point, like how our cultures and lifestyles might have influenced our biology.
Absolutely. A perfect example is lactose tolerance.
The ability to digest milk as adults.
Yeah.
Right. I know that's not something everyone can do.
That's right. For most mammals, including humans, the ability to digest lactose, the sugar in milk, disappears after infancy. But in populations that traditionally relied on dairy farming, like in Europe and parts of Africa, a mutation arose that allows for lactose tolerance into adulthood.
And that would have been a huge advantage for those populations, right?
Right.
Because they had a readily available food source.
Exactly. Those who could digest milk had a better chance of survival and passing on their genes. So over time, this beneficial trait became more common in those cultures.
So it's like our culture, our way of life, actually drove an evolutionary change.
It's a fascinating example of how intertwined our culture and biology really are. And there are other examples too, like sickle cell trait.
Right. That's the one that provides resistance to malaria, right?
Exactly. In areas where malaria is a big problem, sickle cell trait offers a survival advantage.
But I also remember learning that it can have some negative consequences too.
You're right. It can lead to health problems, especially for people who inherit 2 copies of the sickle cell gene. This just goes to show that evolution is often about trade-offs, balancing the pros and cons of certain traits in specific environments.
It's like this ongoing dance between our genes and our environment, shaped by the need to survive and adapt.
Okay.
But okay, so far we've talked about natural selection, climate adaptations, and cultural influences. Is there anything else that contributes to all this diversity we see in humans?
There's one more important factor, genetic drift. It adds another layer of complexity to the story.
Genetic drift. Remind me what that is again?
It refers to random changes in gene frequencies within a population, often due to chance events.
But not necessarily because certain traits are more advantageous, but just because of random fluctuations in the gene pool.
Exactly. Imagine a small group of people migrating to a remote island. They carry only a subset of the genetic diversity from their original population. Over time, certain traits, even those that aren't particularly helpful or harmful, can become more or less common in this isolated group simply due to chance.
So it's like a genetic lottery.
Yeah.
Some traits become more common just by random luck.
That's a good way to put it. And this random fluctuation genetic drift can lead to unique characteristics popping up in isolated populations, further adding to the overall diversity we see across different human groups.
Wow, so we have all these factors at play: natural selection, climate adaptation, cultural practices, and even random chance. It's mind-blowing to think about how they've all interacted to shape who we are.
It really is, and it's a testament to the incredible adaptability and resilience of our species. But for all the differences we see, it's important to remember that we're all incredibly similar genetically. We share 99.9% of our DNA.
Right. We're far more alike than we are different.
Exactly. The variations we see are just superficial compared to the overwhelming genetic unity of humankind. We are all part of one big interconnected family sharing a common ancestor from the heart of Africa.
It's a good reminder that race is really a social construct, not a biological one. We're all Homo sapiens, each with a unique blend of our shared ancestral heritage.
Absolutely. And as we've seen, our journey out of Africa and our interactions with different environments have shaped us in some truly remarkable ways.
Okay, so we've traced our roots back to Africa and unraveled the forces that have created all this diversity in humans.
Uh-huh.
But our story doesn't end there, right? The world is changing faster than ever, and with those changes come new challenges and opportunities for adaptation.
That's right.
So what does that mean for the future of human evolution? Are we still evolving? And if so, what might those future adaptations look like in a world of rapid technological advancements and, climate change and all these other big changes? Skin color, body shape, lactose tolerance, all these things changing based on, where people lived and what their culture was like.
It really highlights the power of evolution to shape our species.
But then, the world is changing so rapidly now, like faster than ever before. It makes you wonder, what does that mean for the future of human evolution?
It's a question that's on a lot of people's minds these days. And the first thing to remember is that evolution, it's not something that just happened in the past. It's an ongoing process. It's still happening right now, even if we don't always see it in action.
So even though we have all this technology and, we control our environments, to a certain extent, we're still subject to those evolutionary forces.
Absolutely. Natural selection, that process that's driven so much of our evolution, it's still at play. But it's not the only force shaping our future. Our choices, our technologies, the way we interact with the planet, they all play a role in where we're headed as a species.
Okay, so let's get specific. What kinds of adaptations might we see in response to these rapidly changing conditions? I'm particularly curious about our increasingly urbanized lifestyle. More and more people are living in cities. Could that be driving evolutionary changes?
It's certainly a possibility. Think about the challenges of city life. High population densities, exposure to pollution, constant noise and light, and even sleep deprivation because of our 2047 culture. It's not unreasonable to think that traits that help us cope with these stressors could become more common over time.
So people who are better at handling stress, pollution, even lack of sleep, might have a slight advantage in these urban environments.
Exactly. And over many generations, those traits could become more prevalent in urban populations.
It's kind of a fascinating example of how our environment, even one that we created ourselves, continues to shape us.
And it's not just the external environment. Our internal environment is changing too. With things like globalization and antibiotic resistance, the ability to fight off new pathogens is going to become even more crucial for survival.
So a super strong immune system that can adapt to these new threats would be like a superpower in the future.
You could say that. We might also see changes related to our diet and lifestyle, with processed foods becoming more common and people being less active traits that help us metabolize those foods more efficiently or counteract the effects of a sedentary lifestyle. Those could become more advantageous.
It's like our bodies are constantly trying to catch up with our changing habits.
In a way, yes. But there's another big factor we have to consider: technology.
Oh, yeah. We're constantly bombarded with information and digital stimulation. Could all that be affecting our biology, too?
It's a hot topic among scientists. Some believe that our brains might be adapting to process information differently in this age of constant digital input. We might see changes in attention span, memory, or even the way we learn.
Wow, so our brains, the thing that makes us human, could be evolving in response to technology. That's wild.
And then, of course, there's the whole issue of genetic engineering and the potential for humans to directly manipulate their own evolution.
Ah, yes, the designer baby debate. It's both fascinating and kind of scary, isn't it? It's a complex issue with huge ethical implications. But the technology is advancing rapidly, and it's something we as a society need to start thinking about seriously. The ability to edit genes raises some fundamental questions about what it means to be human and what choices we have about our own evolution.
It's a lot to consider. But it really highlights how we're not just passive passengers on this evolutionary journey anymore. Our choices, our innovations, our understanding of our own biology, they're all shaping the future of our species.
That's right. The story of human evolution, it's far from over. We're still writing new chapters every day. And understanding our past, our origins, and what shaped us is more important now than ever. because only then can we make informed choices about the future we want to create. It's been an incredible journey exploring the origins of our species, the amazing diversity of humankind, and what the future might hold for us as we continue to evolve. But as we wrap up this deep dive, I'm left with a sense of awe and a lingering question. As we move forward, both biologically and culturally, what role will each of us play in shaping the future of humanity?
That's the question we should all be asking ourselves, because the future of our species is ultimately in our hands.
It's a big responsibility, but also an exciting one. Thank you for joining us on this incredible exploration of human origins. We hope you've enjoyed our deep dive into this fascinating and ever-evolving story.